Alright, so the image that you have on your left is just an illustration showing you how these biogeochemical cycles move throughout the 4 different spheres. We see the hydrosphere, the atmosphere, the lithosphere, and the biosphere, which is interacting with all of them throughout this little purple arrows, and how these guys are interacting with one another. So it's a constant exchange of chemicals throughout the Earth's spheres. The oxygen cycle is shown to you in the image here on the right. It's relatively straightforward, but as you may know, us humans and other animals, as we breathe, we exhale carbon dioxide. This carbon dioxide is then somewhere in the atmosphere. Once in the atmosphere, it's taken up by plants that use it through the process of photosynthesis, as they use this carbon component from the carbon dioxide, and much of the oxygen is released back into the atmosphere. So they use the carbon for their growth and also for just the process of photosynthesis, and much of the oxygen is released back into the atmosphere where it is available for us to breathe in, to inhale. And then the cycle starts all over again. So there are other pathways that oxygen takes, not just from the atmosphere to the biosphere, but this is a good and simple example of one of the oxygen cycles, or one of the cycles that oxygen takes within 2 of those spheres interacting with one another. The carbon cycle is a little bit more complex than the oxygen cycle, but it has the same basic idea. So, as some of you know, much of the living organisms are carbon-based, meaning that much of what makes us up is carbon. So when living things perish, some of the carbon that was initially within us, that was making us, is now deposited within the soils, and some is exhumed into the atmosphere after we perish. In the atmosphere, if it's released into the atmosphere, it may now be taken up by other elements and merge with them to make new molecules, such as carbon that reacts with oxygen in the atmosphere to make carbon dioxide, for example. From the carbon that remains in the soils after we perish, some of it may be taken up by water molecules that percolate through the soils, and it gets picked up and carried elsewhere. So it may get picked up and carried all the way to the ocean, and once it reaches the ocean, it may easily react with loose calcium or with calcium and oxygen ions, and form calcium carbonate, or a form of limestone rock, for example. So calcium carbonate itself is a form of limestone rock. It could also form dolomite, which is another type of calcium carbonate rock, or made out of it. So some of the carbon that got used up in the atmosphere, or that remains in the atmosphere, is also used by the biosphere through photosynthesis in the same way that I explained in the last slide. And some of the carbon that is in the soils that didn't get carried away by the percolating water may get buried deeper and deeper and deeper by further deposition of sediments, and being nearly unchanged, meaning the carbon itself didn't really change. It didn't merge with many other molecules. And so chemically it's still carbon, it just gets buried deeper and deeper and deeper. And as it gets deeper, it gets hotter and it gets trapped, basically. And with those changes in pressure and temperature, basically, the carbon is easy to, or it's easy for it to change into oil and natural gas, depending on the depth and the environment under which it is in. As you know, oil and natural gas are very precious to us humans. We extract them from the subsurface and then we burn them to produce heat and electricity. So as we do this, as we're burning this oil and natural gas, which are a form of carbon that again initially was at the surface and got buried and buried and buried, so as we burn it, we release carbon dioxide back into the atmosphere. And another potential for the cycle starts again, thanks to us. So again, here we saw many different paths that carbon can take, going from the biosphere to the hydrosphere, to the atmosphere, and to the lithosphere. back and forth a few times depending on which of those examples you took. Two other biogeochemical cycles that are important to us are the nitrogen cycle and the phosphorus cycle, which is in the next slide. These two processes are large players in the agricultural industry, especially since those two elements are very important for nourishment, for plant nutrients, basically. So we rely highly on either of these elements and their specific cycles for our food production and our consumption. I'm not going to go in depth on either cycle because there are lots or too many processes I would need to explain, and although these are fun to dive into, they won't contribute too much to this class's learning objectives. So if you want to take a look at them, pause the video here and also go to the next slide when I pass it and I read, or sorry, when I pass it, and then read on your own. So go ahead and look into the different components of the cycle, how these words have anything to do with the interaction of the exchange of nitrogen, and the following slide for phosphorus. So again, if you need to or if you want to, go ahead and pause the video to check them out. And I will pass on now to the next slide. So if you want to pause here, go ahead and do so. All right, same thing here. If you want to pause and check the slide out a little bit more thoroughly, do so. And with that, we are pretty much done with the biogeochemical cycles, which were the last cycle for the geology cycles, right? So we had tectonic cycle, rock cycle, hydrologic cycle, and biogeochemical cycles. So now we're going to go ahead and move on to hazards as predictable from scientific evaluation. We're going to examine the scientific method, and then we're going to go on to risk assessment. All right. So now that we understand the cycles that are responsible for natural processes, we can take a step back and look at the wider picture. So by doing so, we can start to look at the scientific method and its ability to aid us, to help us in forecasting or predicting the natural hazards that occur as a result of these different geologic cycles. So, as an example, let's look at the image that we have on the slide. So this very large boulder, which seems to have fallen from the slope up here on the right side of the image, is now blocking the road and possibly the railroad that is below. So we can also see that there's some crews over here that appear to be working on removing some of the sediment that fell along with the boulder, and they could also be repairing some of the power lines that we see have fallen over here on the left side of the image. So both of these were probably partially damaged from the massive boulder falling from the landslide, as well as some of the smaller sediments that fell along with it, or even vegetation that fell along with it. So now, it does not look like anybody got injured, thankfully, but this natural process, which is the landslide itself, is actually a natural hazard, not just a natural process. And the reason for this is because humans intersect this area where the landslide occurred every single day. So there is a potential for humans to cross the road or to drive through the road, and so the natural process occurring where it did makes this a natural hazard. So the first thing we do when we look at this natural hazard is we make an observation, which in this case would be a boulder rolled down the hill. That would be our observation of what we're seeing. And then this allows us to ask a question. So again, I'm going to go through the steps as I go through this example. So we made an observation, which allows us to go ahead and ask a question. And the question in this case would probably be, why did this boulder roll down the hill? So why is it that this occurred? So in order to answer this question, we need to do a little bit of background research. So this would mostly come from gathering information from the site, so from the nearby area. So maybe we could look or hike up the slope and see a location where this boulder could have been previously located, so where it dislodged from, or from where it could have, detached, basically. So perhaps it was from a very steep portion of the slope, or for example, it could have just been above a construction location where excavation was taking place, and by the construction workers that perhaps didn't know of the presence of the boulder above, they could have been destabilizing the ground right below where the boulder sat, and hence causing the boulder to fall. So once we have found this information of where the boulder was initially located, maybe it was just sitting there, maybe it wasn't even attached to anything, right? We could then formulate a hypothesis. So again, we made an observation, asked a question, did some background research by examining what was going on, and then we constructed, or we're going to construct a hypothesis. So a hypothesis, for example, in this case would be that the fact that the construction company dug the area right below where the boulder sat, it made the ground be destabilized enough, upon which, the boulder relied for stability, and hence it caused the boulder to roll away. Also, another possible hypothesis based on previous background research would be that since it is a little bit foggy, so that would be our background research here in the picture, then it's possible that the area where the picture is taking is typically quite humid. So a place that is quite humid, and if we know that the hill slope was relatively steep, if it had been oversaturated with water, then it's possible that any rainfall event that might have happened the night before could have caused just enough oversaturation of the hill slope to become so heavy that it could no longer hold its weight, hence causing the boulder, along with some of the other material, to roll downhill. So those are two different hypotheses, both drawn from the background research that we had done. Again, both of those are examples. Okay, so once we have the hypothesis, or set of hypotheses, we could then go ahead and try to test them. So let's use the latter example, the one where I said that the area was very humid, and so a little bit of rainfall would cause the hill slope to become unstable enough. So if we think the boulder fell due to the oversaturated slope, then if more rainfall occurred soon after that, more sediment might roll down the hill again, for example. Another way to test the same theory, or the same hypothesis, would be to walk up and down the slope, and also sideways on the slope throughout the area, and look for any other boulders or large amounts of sediment that were newly deposited that would potentially help us, that would hint at the fact that they also fell as a consequence of the oversaturation in the area. So those are two ways of testing. Basically, the first one would be waiting for another event of rainfall and seeing if anything else happened, or walking along the area to see if any more smaller landslide occurred due to the same potential rainfall from the night before. So again, that would be testing our hypothesis over here. So if we did the second test and found that some more boulders or sediment, or perhaps we did not find them, we could then analyze the data that we collected and draw a conclusion based on that data. So, for example, if we had indeed found more landslide deposits elsewhere on the slope, and say we had also tested how saturated the slope was by digging in a few spots and checking the soil saturation, we could pretty confidently draw a conclusion that said excess water was the cause for the boulder blocking the road, along with other boulders elsewhere within the slope. So that could be our conclusion drawn from the analysis of the data that came from testing our hypothesis. So once we came up with this conclusion, then a report of the results would be given to whatever state or private company was that hired us, and then they could take further measurements to stabilize the slope better, or to engineer the draining systems in order to avoid slope oversaturation. And hopefully, if we were correct about our analysis and our conclusion, said measures that they applied would avoid any future landslide events of that slope. So here, what I just did for you, that example that I gave, was go through the scientific method steps, as outlined here on the right side of the slide, and apply them to a specific natural hazard.